oftentimes with polynomials, we want to go through the process of dividing the polynomials to carry on a operation. So here I have a problem where I've got the parenthesis grouping, and I have three terms in the parenthesis grouping that I'm supposed to take and divide it by a one-term expression, a monomial. Now this might be easier to see if we write it as a fraction for the division process. So we're going to take our 15a squared b cubed plus 5ab to the fourth minus 35a to the fifth b squared. And it says to divide that by the 5a to the fourth b to the third. Now notice when I write it this way, I have, again, my three different terms in my numerator, but a monomial denominator. In my denominator, I don't have any pluses or minuses to give me different terms. When I have a monomial denominator and they want me to perform that division, really what I want to do is split this up as separate fractions and simplify them individually. So the first thing we're going to do is take each of these terms in the numerator and write it over that common denominator of the 5a to the fourth b to the third. We're just doing the operation of when we looked at adding and subtracting fractions with the common denominator, we added and subtracted their numerator and kept the common denominator. Well, here I'm going just backwards on that process and writing them as separate fractions to start. So I have 15a squared b to the third over the 5a to the fourth b to the third. And then I use the operation symbol between the terms to be between the individual fractions. So I have plus 5ab to the fourth over 5a to the fourth b to the third. And then minus the last term, 35a to the fifth b squared over my 5a to the fourth b to the third. So normally we have looked to get our common denominators of our fractions, and then we would do the arithmetic across the numerator and keep the common denominator, like where this problem started. But there's many times in mathematics where it's more advantageous to us to have them as separate expressions instead of all caught in that division. So we want to learn how to go this way with the process as well. Now that we've split them up as separate fractions, you want to look at each of these individual fractions that you've separated off that are now all multiplication in the numerator and all multiplication in the denominator and simplify them individually. So when I focus just on this first fraction, numerical coefficients you simplify like you do your normal numerical fractions. 15 in the numerator and 5 in the denominator would leave me a 3 in the numerator and a 1 in the denominator when I remove my common factor pair of 5s. With my exponential expressions in the same base of a, and they're in the numerator and denominator of the fraction, we take our big exponent 4, subtract our smaller exponent 2. 4 subtract 2 is an exponent of 2, and we put it on the base of a where the bigger exponent was in the fraction. So I have an a to the second in the denominator. For the b to the third in the numerator and the b to the third in the denominator, these match exactly as factors in the fraction, so that's a common factor pair that just removes. And so I get 3 over a squared for the simplification of the first fraction. Now we'll put our plus. In the next fraction, we have a common factor of 5s that remove. With the factors of a to the powers, 4 subtract the exponent of 1 gives me an exponent of 3, and I write it on the a where the bigger exponent was. So I have an a to the third in the denominator. And for the factors that are the exponential expressions with the base of b, 4 subtract 3 is an exponent of 1, and I write it on the b where the bigger exponent was. So up in the numerator, I have a b to the first. Then my subtraction, so then minus. My common factor pairs of 5s. The 5s cancel. Remove the common factor. 5 goes into 5 once in the denominator and into 35 7 times in the numerator. So I have a 7 in the numerator. With the common factor pairs of a's, I have an exponent of 5, subtract the exponent of 4, gives me an exponent of 1 on the a that will be in the numerator because that's where the larger exponent was. And for my b's, an exponent of 3, subtract an exponent of 2, gives me an exponent of 1 on the b in the denominator because that's where the larger exponent was. So this final result, where we have the 3 separate fractions in their simplified form, is actually the answer that they want for this sort of a question. So be careful not to be tempted to try to do more with this when you get it to this stage. It started as a fraction with several different terms over the monomial denominator. So when it wants me to go to the process, it wants me to write it as the separate fractions that are each in their simplified form.